Okay, so we got the 2022 spec WACE exam to do. Here's calculator free, 48 marks. How many pages? 13 pages to do. So yeah, let's just get started. 50 minutes. Consider the functions of this. Determine the exact value of f of a negative 5. So f of negative 5 is going to be 3. So then g of 3 is equal to 1 on 9. The domain for f of g of x, or f of g of x, is going to equal square root of 4 minus 1 on x squared. So then here we're going to have 4 minus 1 on x squared must be greater than or equal to 0. So then 4 minus 1 on x squared, 4 must be greater than or equal to 1 on x squared. So then let's say x squared greater than or equal to 1 on 4. So then x must be greater than 1 on 2, or x must be less than or equal to negative 1 on 2, I believe. Let's say it's 1. Obviously 1 squared is greater, but if it's like 1 on 3, 1 on 9, it's not greater. And here, if it's like negative 1, if it's negative 1 on 3, it must be less than. If it's negative 1 on 3, is 1 on 9. Minus 4. Minus 9. So x squared must be greater than 1 on 4. So x must be less than or equal to. Greater than. So if I do like, if it's negative 1, it will be greater. Oh wait, because negative 1 on 3 is actually bigger than 1 on negative 1 on 2. Whoopsies. So yep, that looks correct to me. So then let's say x is a part of the reals such that x is greater than or equal to half, or x is less than or equal to negative half. Explain why g is not a one-to-one function. So let's say that g of negative, or let's say g of 2 is equal to 1 on 4, but g of negative 2 also 1 on 4, and clearly as 2 does not equal negative 2, g of x is not a one-to-one function. Okay, solve the equation for f dash of x is equal to x. So let's see, what would my f dash of x look like? If I did that, that's still going to be an open dot. Then it's going to be up like this, and then we go down to 1. And we want it equal to x. So this is going to be 0 less than x, because it can't equal 0, but then it can equal all the way up to 2. So equal to 2. Sketch the graph of 1 on f dash of x. Okay. So let's just take out 0. So we have 1 at negative 3. We have 1 at negative 1. And we have nothing else. So then, when are we at negative 1? So we're negative 1 at 2.5, so about here. And 1.5, so about there. Our minimum there is going to be negative 0.5. We got 1 at 1.5 here. And then again, like that. And here, negative 1 at negative 1. 2 is at a half, and then 3 is at negative 1 again. Okay, so let's draw this. So it's going to be something like this. Like that. This is going to come down like this and just stop there. And then we're going to have because that's at 0 there, negative. So it's going to be coming up like this. And then stopping there. Now, where do I put that open dot? That open dot just disappears, doesn't it? Because I can't do 1 on 0. 1 on 0 does not make sense in this context, so I'm pretty sure I just leave it. I believe so. Okay. By using one or more of the following identities. Oh wait, do I do like an asymptote? No, because it clearly reaches it there. Okay, I'm just going to leave it like this. Using one of the following identities, solve this. So let's see, sine of x plus cosine. So this is going to equal. Let's do pi on 2. Let's just expand this like normal. So sine squared of x plus 2 sine of x cosine of x plus cosine squared of x dx. Then let's get this. It's going to be equal pi on 2 to O. This is going to be 1 plus 2 sine. So I have this sine and this cosine, so that becomes 1. And then since I have this as well, that becomes sine of 2x, so plus sine of 2x dx, which is going to equal x plus x minus a half of cosine of 2x from pi on 2 to 0. So this is going to be pi on 2 minus cosine of 2x of this is going to be cosine of pi, which is going to be negative 1. Minus 0 minus, just going to be 1, so half. And this is going to be, that negative and negative are going to cancel, so it's going to be 1 plus pi on 2. We're back. My brother just came in. Okay, so where was I? See if I differentiate this, do I get that? Yes, I do. I'm subbing it all in because pi on 2 be pi 0 negative. Okay, I'm pretty happy with that. Let's just move on. Functions can be expressed in the form of that. Determine the constants of a, b, and c. So we need that 5 of x plus 1 is going to equal a of x squared plus 3x plus 1 plus b of bx plus c of x minus 1. Okay, so make sure I get that right. Yep. So let's take when x is equal to 1, so I can get rid of that. When x equals 1, this is going to become, that's going to become 2, so 10 is going to equal, that's 1 plus 3 plus 1, so 5a. So a is going to equal 2. And then as, so let's say x squared coefficient. 0 is going to equal 2x squared plus bx squared, so b must equal negative 2. And then let's look at our constant. It's going to be 5, it's going to be equal to 2 plus or minus c, so c must equal negative 3. If I expand this, let's see what I get. 2x squared plus 6x plus 2 minus 2x squared plus 2x. Cx is minus 3x and then plus 3. So then cancel. 3x 5. Oh wait, hold on. That cancels. Becomes 5x and then plus 5. Okay, nice. So a is 2, b is negative 2, c is negative 3. So this is equal to 2 of, let's say 2 of 5 of x plus 1, because expanding this we get 5x plus 5. So x minus 1, x squared plus 3x plus 1 dx, which will be 2, and this becomes 2x and 1, or 2x minus 1, plus b was negative 2 and c was negative 3. We're back, my mom just came in. Okay. So since it's negative 2, negative 3, let's just make this a negative. And then it can be 2x plus 3 on x squared plus 3x plus 1 dx. Now this becomes 2 of, this derivative here is just going to be 1, so let's do 2 ln of x minus 1 minus 2x plus 3, yep, that's what we have, so minus ln of x squared plus 3x plus 1 plus c. So then this, expanding this, becomes 4 ln of x minus 1 minus 2 ln of x squared plus 3x plus 1 plus c. Okie dokie. B was 2, C was negative 3. Yep. Okay. Hey, consider the Cartesian equation for the 3 planes. Let's say this is plane 1, plane 2, and then plane 3. Normals to the planes. So normal to planes. Plane 1, normal, is equal to, it's going to be 2, 2, 1. And then plane 2, normal, equal to negative 2, 2, negative 5. Negative 2, 2, negative 5. And then let's say plane 3, normal is equal to 0, 1, negative 1. 1, negative 1. So then as none of the planes, or none of the normals are parallel, i.e. they are not scalar multiples of each other, multiples, not multipliers, each other. Close the bracket. The planes themselves are not parallel. Okay, solve the above equation simultaneously. So let's do, okay, I'm just going to rewrite them. So 2x plus 2y plus z equals 9. This one is negative 2x plus 2y minus 5z equals negative 13. 5z equals negative 13. And then y minus z equals negative 1. So let's say this is 1, 2, and 3. Okay, what's the below equation? Geometric interpretation. Alright. So let's do, what should we do? What should we do? Let's do 1 plus 2. So then these x's will cancel and I get 4y minus 4z equals plus 2. So this is going to equal negative 4. So then y minus z equals negative 1, which is exactly the same as which is equal to the third one. I'm going to redo this as, let's do this with the augmented matrix, because I understand augmented matrices. I can't believe I'm saying this, but I understand it more than the algebraic version. So let's just say -2. So let's say 2, 2, 1, 9. Well, I find it easier to explain the answers. -2 to -5, -13, and then 0, 1, -1. And we'll do R2 minus R1. So round 2, sorry, let's do round 2 plus R1. So then this is 2, 2, 1, 9. Here. It's going to be 0, 4, -4, -4, 0, 1, -1, -1. And then let's do row 2 minus 4 row 1, and then that'll give us our 0 row. So 2, 2, 1, 9, and then 0, 0, 0, 0, and 0, 1, -1, -1. As 0x plus 0y plus 0z equals 0. This is true for all x, y, z. Therefore, many solutions along. Therefore, infinite solutions. However, they are still bound by these. So, state the geometric interpretation of the solution. If I'm correct, it should be that they all intersect along a line. They all intersect along a line. The 3 lanes intersect along a line, hence infinite solutions. Infinite solutions bound by other two. Bound by other two equations. Okay. Two complex numbers, 4 cis, are shown on the diagram. Determine the exact polar form for Z2. So the magnitude is 2 cis of, and this is 1, 2, 3, 4, 5, 6, so it's 12. And we have gone, we've gone 1, 2, 3, so we are 9. So 9 on 12, it's going to be negative 3 pi on 4. Plot the complex number, so 1 times that on the eigen diagram. So W is going to be equal to 4 cis of 5 pi on 6. And then we're going to divide that by, because I have an inverse, negative 1, 2 cis of negative 3 pi on 4, which is going to be 2 cis, because 4 divided by 2 is 2, of, let's just make these 12, plus, because taking away a negative is going to be add, 9 pi on 12 is going to equal 2 cis of 19 pi on 12 is going to equal 2 cis of, so we've gone 7 past pi. So you got 5 the other way, so negative 5 pi on 12. So 2, negative 5 and 12, so that's 1, 2, 1, 2, 3, 4, 5, 12, right there. So this is W. It's half, and then we need to go 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Nicely done. If cis equals a solution of the equation where r is a positive real number and n is a positive integer, determine the smallest possible value for r in the form 2p. Okay, so if r is a positive real number, if r is positive and real, Zn must equal r cis of 0. N is a positive integer. So then Zk is going to equal r to 1 on n cis of 2 pi k on n, given that k is going to equal 0, 1, 2, 3, etc. Now if 4 cis of pi is a solution, to the equation, so if 4 cis 5 pi on 6 is a solution, then we have that 4 cis of 5 pi on 6 must equal some r1 on n cis of 2 pi k on n. Okay. And the smallest possible value for r in the form 2 to the power of p. So 4 equals r1 on n, and then 5 pi on 6 must equal some 2 pi k on n. I'm not going to be able to get something good out of this. I don't think I'll go for those 3 variables. So let's just focus on this, because I think this is, because it has our n in it. And so let's say 5 pi is equal to 2 pi on 5 on 12. K equals 5, and n is going to equal 12. Therefore, smallest n is equal to 12. Most reduced form maybe I say second most. Smallest n is that. How do I explain why this is the smallest? Lowest or highest common denominator, or highest common factor. Is 2 between numerator and denominator. So my n is 12, therefore Oh, come on. Okay. Half the time. So I'm just going to continue. Highest common factor is 2 between denominator and what's it called, numerator. So I need this to be in some form of that. So then, and then we can just say that k was 5. Okay, so then, therefore, 4 is equal to r, 1 on n. Or we have 2 to the 2 is equal to 2, 1 on 12. R is equal to 1 on 12, 1 on 12. So then the smallest must be 2 to 24. Smallest r is 24. Okay. I think that's correct. For example, if this was like had a common factor of like I don't know, 3 wouldn't work. Maybe like 4, because you read to like 4 pi on 5 on 24, but then that's just the same thing. Oh no, it'd be 2 pi times 2 in there, so it'd be 2 pi 10. So yeah. Okay, so smallest r is on 24. Yeah. The graph of 2x equals tan of y shown along the tangent horizontal line is shown below. Using implicit differentiation, determine the equation of the tangent drawing x equals 0. So we have that 2x is equal to tangent of y. So then if we differentiate this is going to be 2 is equal to secant squared of y dy dx. So then dy dx is equal to 2 on secant squared of y. And when x is equal to 0, y is equal to 0. I say y is equal to 0. Ooh. My power just flickered for a second. And for dy dx, 2 on wait, so 1 on secant squared of y. So it's going to be 2 cosine. Hold on, let me write this. I'll move you guys down. So this is equal to 2 cosine squared of y. Because 1 on secant squared is 1 on cosine squared of y, like that. And then I'll multiply it to the top. Yep. dy dx is equal to 2 cosine squared of 0, which is going to be 2. So then therefore y tangent is equal to 2x plus c, and it goes through 0, 0. Therefore we have 0 is equal to 0 plus c, c is equal to 0, and y tangent is just going to equal 2x. The shaded region is bound by the curve of that. The tangent drawn, y equals pi on 3. Write an expression for the area of the shaded region. Okay. So when y equals pi on 3, y equals pi on 3, we have that 2x is going to equal tangent of pi on 3, which is tangent of 60, which is going to be square root of 3. So x is going to equal square root of 3 on 2. Because tan of 30 is 1 on square root, and 45, tan of 60. Tan of 60 is a half on square root of 3 on 2. times 2. Wait, 60. No, other way around. Square root of 3 on 2 on top. Because cosine of 60 is a half. Yep. Square root of 3. For area, it's going to equal. So I have from here to here is a tangent minus that. From there, there's pi on 3 minus that. Okay. 2x is equal to that. And let's say that pi on 3 for y tangent. We have that pi on 3 equal to 2x. So x is equal to pi on 6. Therefore, area always going to equal, you go pi on 6 from 0, because this here will be pi on 6, and then this one is square root of 3 on 2. So 0 to pi on 6 of the tangent, which is 2x, minus x is equal to tangent of y. Should I just do that x is equal to tangent of y instead? The area of the shaded region. Because I'm going to need y in terms of x for this, but then y is going to equal tangent negative 1 of 2 of x. Now, I don't think I'm going to be able to do that. We'll anti-differentiate that. So let's do around y-axis. Let's just do this. So area is going to be equal to 0 to pi on 3, and the whole time this that 2x is above. So we'll say that x is equal to, so 2x equals tangent of y, then x is equal to half of tangent of y, and then for y tangent is equal to 2x, we can say that x is equal to a half of y tangent. So then let's do half of tan of y minus a half of y, and this will just be dy. Okay, evaluate this area exactly. So area, we'll pull this half out, so it's pi on 3 to 0 tangent of y minus y dy. So this is going to be half of antiderivative of tan. So secant. No. Antiderivative of tangent. What differentiates into tangent? this. I say let u equal tangent of y. U dy is going to equal secant square of y. Y equal inverse tangent of u, which doesn't help for this case. Oh no, it can, I think. I just don't have a secant square of y. The area of the shaded region is bound by the curve 2x equals the tangent drawn y equals pi on 3. What if I say it's this triangle, this rectangle, and we just take away the area underneath? No, because it's y. And y is equal to tangent negative 1 of 2 of x. It seems like any way I do this, I'm going to run into tangent negative 1. Oh, wait. Okay, hold on. Oh, if I say this is sine of y, cosine. Ah! Okay. I think I'm getting somewhere. So then this would be a half of... So the derivative of cosine is going to be negative sine. So this would be negative ln cosine of y minus y squared on 2 okay, I think I'm getting somewhere now. We're going to go from pi on 3 to 0. And this is going to be... Oh, it's going to be negative though. Do I have to flip my bounds? Do I have to go 0 to... or pi on 3 to 0? Yeah, I think I might have to flip my bounds. Let's say 0 and then pi on 3. Why is that so though? 0 pi on 3. Oh, is it because we start pi on 3 on the left and move down to 0? Is that why? I got no idea. A half of tan of y minus half of y. Okay, so let's flip these bounds. 0, 0, pi on 3. And this will be 0, and this will be pi on 3. So this will be half of 0 minus because that'll be ln of 1. Okay, so if I sub in 0 for this, that becomes cosine of 0, which would be 1. ln of 1 is 0. So 0 minus negative ln of cosine of pi on 3½ minus, that's going to be pi squared on 9 divided by 2, so on 18. This is going to be half of ln of 1 on 2 minus, or plus, sorry, pi squared on 18. So that becomes negative ln, because this is going to become negative ln of 2. So negative a half ln of 2 plus pi squared on 36. Not sure if this is the way to go. Because if I did pi and 3 the other way, I'm going to get half of ln, or negative ln, of half minus pi squared on 18. So it'll be half of ln of 2 minus pi squared on 36. Now, what is ln of 2 going to be? It's pi squared, 3.14, say 9 on 36, so it's going to be about 1/4. Negative ln of 2 was negative 1/2 as well. I'm not sure. Maybe I should just go 0 to 3 on 2. Or pi on 3. So I'm not sure if this is going to be positive or not. That's going to be negative 1/4. I think I'll just go 0 to 3 on 2, and pi on 3. So 0 to pi on 3. So this becomes negative ln of 1/2 minus pi squared on 18 minus negative ln of 1 minus 0. Pull this negative out, say that's that, and then that's negative. Okay. I think it goes 0 to pi 3. I think we do that. So yeah, 5 minutes left. I'm going to call it there because I want to get started straight away and calculator assumed. So see you then. Actually, as soon as I paused the timer, I scrolled up and I saw that I hadn't changed my limits up here, or my bounds up here. So we'll just change them up here. Okay, now I think we're good. So now we'll head off to the calculator assumed. Okay, calculator assumed. I got my cast ready, and an hour 40 minutes on the clock. Let's see. How many? Okay, 24. Okay, then 24 pages to go through. I'm probably not going to finish all of it today. I'm probably going to do like about maybe an hour's worth, 50 minutes worth. I think we're going to hold off at 10:20. So that leaves what, 45 minutes worth of work to do. Because I've got some other things to do tonight. So yeah, we won't do all of it in this one take, but yeah, let's go. A regular hexagon expands so that the length of each side increases at a rate of 0.5 centimeters per second. Determine the rate at which the area is increasing when the side length is 4 centimeters. Okay. So these are all equilateral triangles. So this will be 60 degrees. So let's call this like x. So we know that dx dt is going to equal 0.5 because these are all the same, and then area is going to equal, we're going to have 6 of these triangles because it's a hexagon. So it's going to be 1, 2, 3, 6. So half of AB sine C. Now sine of half of x squared sine of 60. So it's going to be 3x squared times, now sine of 60 is square root of 3 on 2. So this is going to be 3 square root of 3 on 2x squared. So we have that dA dx is going to equal 3 square root of 3x. So then dA dt is going to equal dA dx dx dt, which is going to be 3 square root of 3x. Okay, wait. So when x is equal to 4, dA dt going to equal 3 square root of 3 of 4 times a half. So it's going to be 6 square root of 3 centimeters squared per second. Okay, let me just make sure I got sine of 60 right. So it'll be sine of pi on 3. Means in standard is equal to 2. Yeah. 6 of them is half of xx. Okay. Determine the rate. Maybe I'll just say this is equal to 6 square root of 3 is equal to 10.39 centimeters squared per second. Okay, sketch the locus satisfying condition. So we have z minus 2i, so we have a point there, and then 3 minus 2i. So a point there. Then when you add these together, you get 5. Now the distance between them is the distance between. Oh wait, it's only 2 marks. Yeah, never mind, I'm not going to do that. But the distance between them is going to be 3, 4. So square root of 3 squared plus 4 squared is going to be 5 because it's 3, 4, 5 triangle. So I get that it must be this thingamabobbie between them. It must be the line that joins these two together. So we have angle of 53. Okay. Must be the line that joins them together like that. And if I do it like up here, then we have some distance, and that's going to be adding a 5 on top. So yeah, no, just that. Describe the locus of the equation of z plus I, and then we have to multiply that with the conjugate of z plus I. So what if I say let z equal a plus bi, and this becomes a plus b plus 1i outside of a minus, this would be b plus 1i, and then this is going to equal a squared minus a 1I plus A of B plus 1I minus BI squared minus B plus 1 squared. So plus B plus 1 squared I. And so that's going to cancel. It's going to be A squared plus B squared. Where am I going with this? A squared plus B plus 1. So if I say that this is equal to 2, and this is a circle with center. Because if you imagine that as x and that as y, yes. Oh, hold on. Get rid of that I squared. Okay, yes. Okay. This is that I was confusing me, but I was there by mistake. So it's a circle with center of 0, -1, and radius of square root of 2, because that should be square root of 2 squared. Okay, nice. The sketch of the locus has been shown. Write equations of the inequality in terms of x without using. So we have part of a circle, so we'll say that z minus, what's that point? It's 1 plus 1. 1 plus I must be equal to 2 plus I, and we have that the argument from there is -1/2. So -1/2, that's going to be equal to the argument of, I'm going to run out of space, so I'm just going to put this, I'm just going to move it all over a bit. An argument of z from 1 plus I is equal to pi. Okay. Page 6. The velocity of a particle is given like that. The particle's initial position is -3, 2. So we start here. State what the following definite integral measures about the motion of the particle. So V of t is going to be that. So there's going to be the change in displacement from t equals 0 to t equals 1. And then this one will be distance traveled from t equals 0 to t equals 2 pi, or a full rotation. Now it goes as v of t, okay? Now r of t is going to equal the antiderivative of v of t dt. So I'm going to say a full period. So r of t is 3 sine, so that's going to be -3 cosine of t. Wait, not over. Cosine, so this will be 2 sine of t plus c. Now r of 0 is equal to -3, -2. So we have that -3, -2 is equal to, cosine of 0 is just 1, so it's going to be -3, sine of 0 is 0, plus c, therefore c must be 0, -2. So then r of t must equal -3, cosine of t, 2 sine of t, plus, hold on, now I just do it from here, t minus 2. Determine the Cartesian equation for the path of the particle. Okay, so if we have that this is just going to be the Pythagorean identity. So x is equal to negative 3 cosine of t. We have that cosine of t is going to be equal to x, or negative x on 3. And since y is equal to 2 sine of t minus 2, we have that y plus 2 all over 2 is going to equal sine of t. So I'm just going to say that's y over 2 plus 1. And then since cosine squared of t plus sine squared of t must equal 1, we have that x squared, well, I'm just going to negative x on 3 squared plus y on 2 plus 1 squared is going to equal 1. And that should be a fine expression. Oh, Formula 1 can't away. Has initial displacement of 192, initial velocity of 24. It accelerates for a period of 11 seconds in a straight line so that its velocity and displacement are related. So determine a of x. So v, so a of x, so a can equal dv dt, wait no, oh, I need to check my formula page. Acceleration v dv dx, yep. So dv dx here is just going to be 1 on 8, outside of x on 8. So it's going to be x on 64. Determine the displacement as a function of time. So since we have that dv dt is equal to x on 8, sorry, the x dt, because it's velocity, just from this one, because velocity is just the derivative of displacement. So we have to if I did d dx half of v squared should be x squared on 64. X to multiply x on 64. Yeah, okay, it's the same. Anyway, back to this. So, yep, velocity is the derivative of displacement. So if I rearrange some things, I'm going to divide by this x. So that's going to be that. It's going to equal 1 on 8 dt. Okay, so then this is going to be ln of x is going to equal 1 on 8 t plus c. And since we have that when t equals 0, x is equal to, what was it like, 192. So then that's just going to become 0. So c is going to equal ln of 192. Therefore, x of t is going to equal, well, hold on. So we have that ln of x is going to equal an eighth of t plus ln of 192. So if we get x by itself, x is going to equal 1 on 8 t, and that's going to become e to the ln of 192. So x of t is going to equal 192 e 1 on 8 t. I'm going to write that below so it's clearer. X of t equals 192 e 1 on 8 t. Excellent. Ooh. Let's see. Maybe if here I'll say ln of x. So as x of 0 greater than 0, v of t and a of t, x of t will be greater than 0. Therefore, remove absolute value signs. Therefore, I'll say maybe change of x to just curved brackets of x. Okay. Calculate the top speed reached and the distance traveled during the 11-second period of acceleration. Top speed reached. So v of t is going to equal an eighth of 192. 160 and 32, so is that 24? Yeah, 24. E to the eighth of t. And the distance traveled, so then graphing v of t on CAS, because I really don't want to do all that algebra stuff, and it's only 4 marks, and we're probably going to get a mark or 2 for distance anyway. So I don't think they're expecting much to find this, but let's do 24 e to the 1 on 8 of x. Just change my bounds. Let's do 0 to, I don't know how high it's going to get, but let's do like 200. Oh, hold on. 0 to 12 for the x, and then again 0 to 200 for my y. And then I want to say this is given that 0 is an equal to x, that's an equal to 11. Now I can graph it. Invalid syntax. Oh, because I did that bound inside of here. Inside my exponent. There you go. Graph that. Max that. Maximum at what? Not found. Fmax. 11, 94.92. Therefore, V maximum is equal to 94.92 meters per second. And distance traveled, so distance equal to 0 to 11 of absolute value of V of t dt. So it's going to be 0 to 11 of absolute value of 24 e to the 8th of t dt. So putting this in my CAS, e on 8x dx, I get that this was 567.37 meters. The inner cylinder, or inner diameter of a cylinder in a motor car engine is critical to its performance. Let to mu millimeters to the population mean produced by manufacturing process. A random sample R1 of 100 is taken, and the standard deviation for this sample was found to be 1 millimeter. Sample mean, state the distribution of x and its parameters. So let's say boom is a normal distribution as n equals 100. Some of the past spec papers have done it like this, so I'm going to start doing like this, which is greater than 30. And then the mu of x, that is equal to random sample. It's just going to equal mu. Doesn't actually give it to us. And then standard deviation of x is going to be 1 on square root of 100, which is going to be 0.1. So then x dash is approximately mu 0.1 squared. Okay. What is the probability that differs from mu by more than 0.2 millimeters? Okay, let me just make sure that all of these are in millimeters. I'm not being tricked by anything. So So then therefore probability of mu minus 0.2 is going to equal to mu, it's going to equal to 0 mu plus 0.2 is going to equal I just do like norm CDF. Can I just have x minus 0.2 x or x2 plus 0.2 comma standard deviation is 1, mean is x, one argument type. Can I just put like 1? Okay, if I change these here to 2, should be the same, right? Because it doesn't matter what my mean is. So 0.9545. I'll write this that I did it like, this is the first one I've done, so I'm going to say norm CDF of negative 0.2 to 0.2 of 0.1 and then 0, which gave me 0.9545. From a random sample, 95% is formed. Calculate the width of this interval, correct to 0.1. So margin of error is going to equal 1.96. Sample standard and then 0.1. 1.96. So then therefore width is equal to 2. Margin of errors should be 0.392. 196 times 2, 392. And the production manager wishes to decrease the width of the confidence interval. She suggests we can form sample R2 by using the data from the sample R1 and combining this data with itself to form a sample of 200 observations. If n equals 200 will decrease the width of the confidence intervals. There are two major problems with using this idea. How would you, obviously this is wrong because you're meant to have different observation. Maybe I say the additional 100 observations are not unique and identical to the first to the original 100. What's something else? Okay, this is the last bit. What is something else? Could it just be like it would be misleading to state. It would be misleading to state that n equals 200 in reality n equals 100 and the data was duplicated. Sorry Duolingo, not now. I think I'm losing both marks here, guys, because this is a very interesting question. I understand kind of why, but I just can't put it into words. Because like it won't be different from the data you already had. So all you're doing is you're decreasing the width of the confidence interval to the mean that you already had. So we'll say maybe you have the same mean, have the same exact u, and then misleading, because it will shrink the confidence interval. Okay. The equation implicitly defines the curve shown below. The line intersects this curve shown below. Ah, I've seen someone do this question on YouTube, but that was a while ago, so let me see if I can remember. It can be shown an equation will determine the intersection between that and that. Explain with reference to the graph below why we know that there is one real solution and two complex solutions, the conjugate pair to this cubic equation. So let's say that there's only one there will be three solutions. One intersection. Between x3 plus or minus x squared minus 5x is equal to 3 minus y squared. And what is in between and equals square root of 24. However, given the highest power of x is 3, there will be three solutions. To the equation. Thus, the other two must be complex. Three solutions of real intersection. Given one is real, or given only one is real, the other two must be complex, and since coefficients are real, coefficients of equation are real, they will be conjugate pairs. Okay, determine the two exact complex solutions. Let's do this in a CAS. Solve x to the 3 minus x squared minus 5x is 21 equals 0. Go to complex and do standard. CAS. I don't understand why I get 2 marks for this. I'm just going to say solve x to the 3 minus x squared 5x plus 21 equals 0. X is equal to negative 3, then 2 plus or minus square root of 3i. Therefore, complex solutions, we're going to have 2 minus square root of 3i and 2 plus square root of 3i. Calculate the area of the shaded region correct to that. let's do this would be easier if I do y times of x. So let's do x3 minus x squared minus 5x is equal to 3 minus y squared. So let's bring y to the left hand side. So y squared is going to equal 3 minus x to the power 3 plus x squared plus 5x. Is this going to be some stupid thing where it's not symmetrical? No, it's y squared, so it has to be symmetrical. Okay. So then when y equals 0, x is equal to, so let's solve that 3 minus x to the power 3 plus x squared plus 5x equals 0. I have negative 1 and 3. That looks all good. And we'll say that y equals square root of 3 minus x to the power 3 plus x squared plus 5x. So the area is equal to negative 1 to 3 of square root of 3 minus x to the 3 plus x squared plus 5x dx times 2 due to symmetry around x-axis. So then if I just compute this, negative 1 to 3 of square root of 3 minus x to the 3 x squared 5x dx, and I'm going to times 2. Decimal. CAS does not like square roots, so I get 17. Does it say the area? No. And I want 3 decimal places, so 17.067 units squared. Okay. The annual income of thousands of dollars around sample of n is taken. The standard deviation, the sample, and 90% space to calculate the sample size of n. So then I'll say margin of error is equal to 2. And 2 is equal to 2.576. Since for 99% is a 2.576. Yeah, I'll say that for 99% confidence. K is equal to 2.576. So that. And then we're going to have 10.98 over square root of n. So then on a CAS, we have that n is equal to, n is taken. So solve 2 is equal to 2.576 times 10.98 square root of x. So n is equal to 200. Another random sample of n is taken and with confidence set 2 aspects of the intervals, which I and may be different. So say mu might be different. Also, you get point estimate for point estimate of mu might be different. Different. And then since this is a different sample, the sample standard deviation might be different. So then interval width may be different. I'll say here due to different sample. Okay, a third sample, size 50 is taken. Now, confidence James just into wireless. It is more likely to contain population mean. Is James correct? No. It is not certain. It is more likely to contain population mean. Due to the random sampling. Of confidence intervals, or due to the random sampling, due to the innate nature, that's what I was saying, or inherent nature of random sampling. I guess if it is wider, nah, I'm still gonna stick with it. Inherent of random sampling. It is not certain that any or more likely will contain the true value of contained population nature. It is not certain or more likely that any will contain compared to any other. Nature and handling is not certain or more likely that any 90% confidence interval will contain population mean. Okay, page 16. The graph of a reciprocal function f is shown below. F is the form f of x equals to k. Following properties. F has no intercepts or vertical asymptotes. F is symmetric about x is equal to 3. Function q is quadratic and k is a constant. So it has no x intercepts, so y cannot equal 0. About x is equal to 3. F of x approaches 0. If it's symmetric about x equals 3, that means it's probably going to have a, and it's the maximum point, so it's a minimum. Let's find a derivative. It's going to be a, or 2ax plus b. So we'll say that from f of x, q of x must be minimum at x is equal to 3. Therefore, 2a of 3 plus b must equal 0. Does that help me? So we can say that b is equal to negative 6 of a. So we can say q of x is equal to ax squared, 6ax plus c. function must be like this. And coefficient and a must be greater than 0. Okay, so now I have a few points. So now I have that k of on ax squared minus 6ax plus c. Which now I have 3 squared minus 6a of 3 plus c is equal to 2, because this will be 0.32. And here I have another point at 2, 1. So I'll say that k on a of 2 squared minus 6a of 2 plus c is equal to 1. And then I also have that for 5, 1. And since I have 3 unknowns and 3 equations, I can now solve this simultaneously. 6a of 5 plus c is equal to 1. So then simultaneously on CAS, so let's say x on, let's say y, x to the 3 squared minus 6x of 3 plus z equals 2. I'll just copy this bit over, this for 2. 2 equals 1. And again, 5, 5, and this equals 1. And then so I want x, y, and z. Oh, what? No solution. What? Okay. Function q is quadratic, it's symmetric by x equals 3. No x-intercepts or vertical asymptotes. So q never equals 0. As we move x equals 3, so 2ax plus bx. And 6a. Why can I not get an answer for this? Minus 18x, 4x, minus 12x, and 25x, minus 30x. These all don't. Minimum at x equals 3. Because it's minimum, and that's why we have our maximum point. So we must have a turning point there. So then deriving that, 2ax plus b. Just a bit confused why I'm getting 0 solutions. If I add that one, that will equal 2, that will equal 1. X and 1. If I do it with 2, I get that x is equal to 8. So what if I did this? If I go graph, table, if I graph, graph 8 on x squared minus 6x plus 13. Very normal. And I got can't seem to get it to equal that. 2 there, 3, 2. What on earth? Why is this not giving me an answer? Oh, because it's at 4, not, oh my lord, not 5. There's no way, bro. 4 squared. I've been looking at this for the past how long? And the reason was because I need this to be 4. So 16x minus 24. Z. What? Z equals Z? Doesn't help. 4 squared, 64x, C. No way, what? A is equal to C on 10. What? Why are you giving me this now? What is this? Okay, so let me get this right. 2, 1, 3, 2, and 4, 1. I'll bring you back down here. So x of 3 squared minus 6x of 3, 2 squared minus 6 of 2, and then here will be x of 4 squared, 6 of 4. What? What does it mean z equals z? What? Oh, dude. Okay. B is equal to C on 5. Y, K is equal to C on 5. And C is equal to C. So So this doesn't really make much sense. Therefore, all over c on 10 x squared minus 6 of c on 5, 6 on 10 plus x plus c. So if I multiply, this is really confusing me. So 5. So let's sub in the 0.32 to do x on 10 outside of 3 squared minus 6 of x on 10. I feel like I've spent way too much time in this question. Outside of 3 plus x is equal to 2. X is equal to x. Multiply this by 2. 10. Oh my god, this is hurting my brain. So there's no vertical asymptotes. So if no vertical asymptotes, the discriminant, so it has no zeros, the discriminant must be less than 0. Therefore, discriminant is equal to b squared. So negative b, so literally negative b plus or minus 4ac. So then b negative b plus minus 4ac must be less than 0. Wait, does it? It's b squared minus 4ac. So then b squared minus 4ac must be less than 0. So then c, b squared on 4a must be less than c. Not sure if this is the answer that they want. But it's the answer that they're gonna get. So 7 more pages in 40 minutes. An ant colony population grows at a given rate. That is that. Using the explain the variation of the population. Maximum variation of the population. Wait, what's my variation of the population? From the PDT, is it just a like maximum P equals 100, and then at P equals 50, inflection point occurs as the population starts to concave down. Concave down when approaching and approaches P equals 100. down. So here I'll say growth slows down. So maximum population growth occurs. Maximum population growth occurs. And inflection point occurs. There's a concave down. Growth slows down and approaches peak at 100. Not sure that's what they want though. At the end of the 4th day, the environment for the ant dramatically so that the limiting population is increased to 300. The expected variation population continued using the increasing limiting population value. Okay, so let's go. So the maximum is now 300, so we go to like 150. Let's say that's like by the end of the 8th day. Concave up. Just like concaving down as we approach 300. Something like that. Okay. And I think I'm going to stop it here because it's 10:30 right now. So we'll finish the rest off later. See ya. Okay. Time to continue on. So let's put the timer on. Let's go down. Base has a water depth of 6 centimeters. Cross section of the base is multiplied by that. Calculate the volume of water needs to be added to increase the depth of water from 6 centimeters to 32 centimeters. All dimensions are in centimeters. So we could go from volume is equal to pi, and it's going to go from 6 to 32. Sorry. 632 of 15 minus 4 cosine pi y on 40 squared dy. So let's just figure out what this is. Pi integral 6 to 32 minus 4 cosine of pi y on 40 squared dy. Now decimal just becomes heckiest time. Wow, it's really taking its time. Okay, there we go. 18,107.94 centimeters cubed water. That seems like a lot, doesn't it? About the y-axis, pi dy x squared. 15 minus 4 cosine is in radians. Yeah, looks alright. Okay. Dresden interior design uses a hose to add water to the vase. The hose has a water-saving device that regulates the rate at which water flows into a vase. It's rate scheme right there. V of t is equal to 4 seconds. So we put 6,000. Use increments formula to calculate an approximation for the volume of water she will pour in the next 0.5 seconds. So SOV is going to be approximately dV dt, S of t. Then at V equals 6,000 and S of t equals 0.5. S of V is going to equal or be approximately she'll pour, okay? So change it is 300 E negative 6,000 on 12,000, and then times this all by half. So approximately it will just be 150 E negative 1 on 2, so about 90.98 milliliters or centimeters cubed. To prevent an overflow of water, the device can be calibrated to switch off the flow after a set length of time using an inbuilt timer. Calculate the rate of flow into the vase at the instant where the depth becomes 32 centimeters. So we need to find the volume at 32. So volume, so at h equals 32, I'll say y equals 32. Volume is equal to pi of 0 to 32. We want to rotate all of this on the axis. So then it's again 15 minus 4 cosine of pi y on 40 squared dy. So finding what this is, it was pi on 40, right? Yep. Using separation of variables to obtain the defining rule for v of t. Oh wait, hold on. Volume here is 240.18 cm2. Therefore, dv dt equal to 300 negative e negative 2540 all on 12,000 negative 0.18. So 54.17 cm3 per second. Oh, I need to put here per second as well. So per second. Wait, no. Never mind. No, I don't. Because it's just per the absolute change. Okay, obtain a defining rule for v of t. So we have the dv dt is equal to 300 e negative v on 12,000. So let's see here. If I have 1 on e negative v on 12,000, then since this is on an integral, I can say that's -1 and these will cancel, and then I can say that's just e to the v on 12,000 dv, and then this will be 300t, or dt, sorry, 300 dt. So then here I'm going to have, I need the derivative of that in front, so this will be 12,000 e to v on 12,000 is equal to 300t plus c. So then let's divide by 300, so I'm going to get 40e v to 12,000 is going to equal t plus c. I'll say this is c2. And then let's see, do I have an initial volume? So is v of 0 18,000? Is that what I'm looking at? Hold on. Let's isolate E first, or V I mean. So okay, hold on. Let's do. Okay, let's do E V on 12,000. Alright, we're back. My mom just came in. So E of 12,000 is going to equal 300 divided by 12,000 is 1 on 40t plus, we'll say tc2. So then if we ln both sides here, I'm going to get v on 12,000 is going to equal ln of 1 on 40t plus c2. And then we're going to get v is going to equal 12,000 ln of 1 on 40t plus c2. And then am I doing this right? Am I doing this right? And I ln this, there's ln the full thing, right? Yes, okay, so then we'll say when t equals 0, volume is equal to 18,107. 18,107.94. This will equal 12,000 ln of C2. And C2 is equal to 18,107.94 is equal to 12,000 ln of x. As a decimal, so C2 is 4.522, therefore 12,000 ln of 1 on 40t plus 4.522. Okay, I'm not sure, I think I did this right. So when you ln this, you have to ln the full thing. Okay, I'm just going to do that. So show for all positive integers n and complex number z, well that is that. Okay. And this becomes, so Zn, let's just expand everything and then we'll probably get what we want. Cis of theta inside of Zn plus cis of negative theta equal to, so we're going to get Z2n plus Zn cis of negative theta minus Zn cis of theta plus cis of 0 or minus cis of 0. What is it going to be? Z of 2n plus Zn of cosine of theta minus I sine of theta minus Zn, this would be cosine of theta plus I sine of theta, because sine of negative theta is negative, but cosine of negative theta is theta, and it's be minus 1. So then this is Z of 2n plus, so let's see, we have a plus cosine and minus cosine, so they cancel, and then a minus I sine and a minus I sine. So minus 2I sine of theta Zn minus 1. That's exactly what they want. So yep. And then I'll say here sine of theta, negative sine of theta, and then cosine of theta equals, cosine of negative theta will equal cosine of theta. Alright, hence use the result from part A, obtain all solutions to the equation in exact polar form. Okay, so then we have a Z2n. So then this becomes z to the power of 3 minus, now this is 2i sine Zn. Z is 3, yes. Minus. Okay, let's rewrite the full thing. So Z2n minus 2I sine of theta to the power of Zn minus 1 is equal to Zn plus cis of negative theta. Wait, what was that? No, cis of minus theta. And wait, minus cis of theta. And here it's Zn plus cis of negative theta. So then we have that Z6 minus I Z to the 3 minus 1 is going to equal Z to the 3 minus cis of. So if this is equal to 1I, sine of theta must be a half. Sine of theta is a half, it must be pi on 6. Pi on 6. And here we have Z3 plus cis of negative pi on 6. If Z6 minus I Z3 minus 1 equals 0, then we have that Z to the 3 minus cis of pi on 6 equals 0. So then Z is going to equal cis of pi on 18. I'm going to add 2 pi. How many marks is this? It's 4 marks. So ZK is going to equal cis of 2 pi. Oh, wait, hold on. Pi on 18 plus 2 pi k on 3. Given that k is equal to 0, 1, and 2. So then Z can equal cis pi of 18 cis of actually wait, hold on. What if I do this as well? So then Z3 must equal negative cis of negative pi on 6 negative, so I need to add pi. So Z3 equal to cis of 5 pi on 6. We have a negative of 6 here, and then I add a pi. 5 pi on 6, yeah, so it's negative. So then ZK, well, let's say this is Z, like M is equal to cis of 5 pi on 18 plus 2 pi M on 3, given that M is equal to 0, 1, or 2. Therefore, Z will equal cis pi on 18 cis. So I need to multiply this by 6, so this will be 13 pi on 18 cis. If I add 12 to this, we get 25, just 7 passed, so I need to go negative 11 pi on 18, or we can have a cis of 5 pi on 18 and then again we add 12, so cis of 17 pi on 18. If I add 12, I'm going to get 29, which is 11, so minus 4, so cis of negative 4. Right, is that what? No, negative 7. If I add 12, I'm going to get 29, which is 11 more than 18. So I need to go 7 the other way, so cis of negative 7 pi on 18. Okay, let's just check this on the CAS. So for x to the power of 6 minus I, x to the power of 3, minus 1 is equal to 0. Standard complex. And radians. What if I just do action complex to polar. 17 pi, negative 7, 5 pi, 18, 13, and negative 11 pi. Right, excellent. A downward sloping ramp is positioned along the coordinate system shown below. At a point in the ramp, L is positioned on the top of a post. 2, 2, 5 on 2, determine the Cartesian equation for the ramp. So let's say, so it's going to be a plane. So let's just say A to B is equal to negative 6, 2, 0. So A to B means we want to go to B, take away A, so yeah. And then A to C, I can't draw now, equal to negative 6, 0, 0, 3. Wait. Therefore, we have that ramp is equal to, we'll just take the point of A, we'll say lambda of negative 6, 2, 0 plus mu of negative 6, 0, 3. And this is Cartesian equation for the ramp. So then 6 minus 6 lambda minus 6 mu equal to x. Maybe I think an easier way is to just find the normal vectors to this. So then AB cross AC is going to be equal to top, so then 6. Let me just write it 620 times negative 603. On the top, this would be 60. The middle, 18. And the bottom is going to be negative 12, just 12. So then it's going to be, let's do this, vector, cross product, I don't know where that went, cross product of negative 620, negative 603. Oh wait, hold on, I have to turn my timers on. I'll be back, give me a second. And we're back. Okay. So putting in my timer, I got 6, 18, 12, yep. So now I'll say 6 of 132. Therefore, R dot 132 is going to be equal to 600 dot 132. So we have that R dot 132 is going to equal 6. So then x plus 3y plus 2z is going to equal 6. Emits a bright light and illuminates the lamp. The position that is closest to the lamp will be most brightly illuminated. Determine the position for the point on the lamp that is most brightly illuminated. So let's do let's have a line that's direction that is perpendicular to the normal vector, and I'll say this is normal to plane. So let's say line from lamp perpendicular to plane, and we'll have this as R is going to be equal to, and the point is 2 to 2.5. And we'll say plus lambda of 1, 3, 2. Okay, so now if we sub this into our plane, we have that 2 plus lambda, 2 plus 3 lambda, and then 2.5 plus 2 lambda dot 132 is going to equal 6. And then we can do this one by hand, so we'll do 2 plus lambda plus 6 plus 9 lambda plus 5 plus 4 lambda is going to equal 6. So if we add everything together, that's 8 plus 5 is going to be 13 plus 13 lambda is going to equal 6. And then lambda is going to equal, 14 lambda. And 14 lambda is going to equal -7. Lambda should equal -1/2. Let's check this on calculator. So for the dot product between 2 plus x, 2 plus 3x, 2.5 plus 2x, we got 2x dot 132 equals 6. X is -1/2. Okie dokie. So then r is equal to 2 to 2.5 plus negative 1/2 of 132. And this is going to equal 1.5, 0.5, and then 1.5. Let's just double check that. Given that x is equal to -1/2 is 1.5, 0.5, 1.5. Alright. If a ball is released from point C and is allowed to roll down the ramp, gravity calls it to follow the path of steepest descent. Suppose that the ball is allowed to roll exactly 1 meter away from point C to point P, where S is the direction of the steepest descent on the ramp. Determine the vector S given the components correct to 0.001. I continue that down. If I perpendicular to that, perpendicular to that. Also perpendicular to that. So we have that the magnitude, so let S equal, say, A, B, and C. We have that the magnitude of A, B, and C is going to equal 1. Now C was how far up? C was 3z up. So this length here is 3. I'm going to find the line A to B. I find a line A to B. And then I find a vector perpendicular to it. No, I don't think that'll work. Because there'll be like infinite amount of vectors perpendicular. Okay, O to B is how much? O to B is 2. So that S dot A to B is going to equal 0, or the direction of it. So let's say that A, B, C dot the direction vector, which follows A to B is negative 6, 2, 0. So it must be equal to 0. It's 1. Right angle triangle there. CP to the line AB. Oh, what am I gonna do here? How do I do this, guys? How am I gonna do this? Steepest descent, steepest descent. It's gravity. So it's negative 6a plus 2b is going to equal 0. So then 2b equals 6a, b is going to be equal to 3a. So then we have the magnitude of a squared plus 9a squared plus c squared is going to equal 1. One more equation. I can solve this simultaneously. Where's this theta? Steepest descent. So we some normal vector going that way. Draw that normal vector here. And between that This is a tough question. Okay, what is the angle between what was it, 1, 3, 2, and we'll say 0, 0, 1 equals, let's say on CAS, so let's see, action, vector, angle, 1, 3, 2, and then we want the z-axis, which is going to be 0, 0, 1, and it's 1 point, what is that in degrees, so that makes more sense, 57, okay, so 1.007 radians. It's 1.007 radians. This angle here. My steepest descent for Z must be cosine, therefore steepest descent for Z is equal to, where we have cosine of 1.107 is equal to adjacent, which would be Z. Let's say this is x over 1. So then x is going to be equal to cosine 1.007 0. Wait, no, hold on, that's degrees, radians. 0.5344. Z. Therefore, C is equal to 0.534. Okay, so it's 3 decimal places. Because I'm looking at this triangle here. Wait, no, that would be that angle, would it? But then this is 90 degrees to that. So 2 pi. No, so pi minus pi on 2 minus 1.07. 6, so it's cosine 2.53784. Okay, so this angle here must be 1.007. 0.001. So that angle there is 1.007. And it's 90 degrees to there, so then theta is equal to, for theta, between theta on diagram is equal to pi minus pi on 2 minus 1.007, so 0.5638 radians. And if I have this, I'm going to have Z, that's going to be 1, so that's C to P, and then this is 0.5638, so then Z is equal to cosine of 0.5638, which is going to equal 0.8453, 0.84, yeah, so let's say C is equal to that. And we bring this to here, square root of 10a squared plus 0.84, 5 squared is going to be equal to 1. A is going to equal, so 10x squared plus 845 squared equal 1. So it is plus or minus 0.169. Clearly from diagram A greater than 0. Therefore A equals 0.169, therefore B is going to equal 0.169 times 3, 0.507. Therefore S is equal to 0.169, 0.507, and then 0.845. Okay, let's see. If I find the normal of this, 69, 0.507, 0.845. Okay, that is 1, and that does seem like it would be the steepest descent. So I think I might have actually got it. Pretty happy with that. Okay. Alright, we've got 3 minutes, and I don't think there's much else we can do. So I think I'm just going to start marking straight away. Let's make sure I did all the question, but then missed one in between. Alright, yeah. I'm going to get to marking now, so see you in a second. Sorry, I actually just realized that this Z should actually be negative. And we'll say as and C going down, and C heading down, therefore negative. Less than 0. Therefore C is going to be equal to negative 0.845. Maybe I should say that here. But heading down. Therefore C is equal to negative 0.845. Okay, so we'll do that then. And then I'll just put here negative. Okay, I think that all makes sense now. Going down, slightly going to the left, and we are definitely moving away from the Z-axis. So yeah, alrighty. Now I'm happy. Bada bing, bada boom. Let's end it here. Okay, we just finished marking. We got 91.7%. I think it's pretty much the same as we had before. Yeah, we only lost 2 marks in calculator free and 9 marks in calculator assumed. And we lost 1 mark here because I wasn't sure if I should give myself the mark or not, because you had to indicate that x equals 0 was an asymptote. But on the marking key, it was like one of the behaviors you had to do, but it didn't actually show what it's supposed to look like. So I just assumed that they drew black dotted lines like here over the axis, but then you wouldn't be able to see it. So I lost 1 mark. I knocked off 1 mark there, and I knocked another mark off for here, because you had to solve or something like that. You had to say infinite solutions, but then you also had to give the equations for the solutions. So yeah, I lost 1 mark there. And then luckily down here, I actually surprised I got this correct. R24 was or 2 to the power 24 was the lowest, and I also am surprised I got this correct. Good thing I changed it, because it was 0 to pi on 3, not the other way around. So yeah, 2 marks lost, so we're going to quickly move over to calculator assumed now. Okay, into calculator assumed, and we lost 9 marks here, so let's quickly go through it, because I want to start working on 2023. So we lost 1 mark somewhere. Okay, we lost 2 marks here because it had to differ by more than 2 millimeters. I did it if it was differed by less than 2 millimeters, so that's just an oopsies by me. Then yeah, I probably had to standardize it, so the absolute value of Z would be greater than 2. And then I lost 1 mark here because I said have the same mu because it's identical. But then you had to say something else where you had to say another point where it was like not random sample anymore, so then you can't use normal distribution. You can say it won't reflect the true variation in the sample, and then apparently replicating the data will not decrease the width of confidence interval, which I'm not sure if that's true or not, but yeah. And going down, so yeah, pretty much just it won't be a confidence interval anymore because it won't be random. Here I said mu might be different, but they talked about the midpoint, but they said midpoint because of mu being different, so I gave myself the mark. Here I lost 2 marks because if I just had to multiply it by this, so then I can cancel out the C on top and bottom, and then I can multiply it by 10, and then it would cancel everything out to become this. So I lost 1 mark because I didn't do this, and I lost another mark because my final answer wasn't that, and it didn't match. Because I'm not going to give myself a mark for this, because that's a bit off. Yeah. In here, I didn't realize this, but you could have maybe simplified it. This wasn't actually the marking key, but just when I was going through, I was like, wait, I know a value for B, it's going to be negative 6a. So if you square that, you can simplify a little bit. And it does work out, because A turns out to be 1, and then C will turn out to be 10. So obviously 9 is less than 10, so I guess I could use that for a check. Here you need to say that for P being below 50, the rate of growth is increasing, which is concaving upwards. But then I said after 50, it begins to concave down, and as it approaches P is 100. Then going down here, I should have read the definition of VFT. It's not the total volume, it's the volume poured into the water after some flow. So here I got it wrong because I should have used, when the depth becomes 32 centimeters, because then you would have added what we calculated in A here, you would have got 66. I didn't even give myself a follow through because I thought I didn't really understand, so I'm not going to give myself any marks. Here, the T0 volume that you've poured into it would have been 0 instead of this, which is how much you needed to add. I don't know why I chose that value. So yeah, C2 would just be 1 instead of 4.522. But I only lost 1 mark because getting or subbing in this and then getting the correct C value was only the final mark. Here we got everything correct. Just correct substitutions, all of that was right. Here was good, here was good. And very surprisingly, we actually got C correct. All parts. In fact, this solution isn't actually in the marking key. This solution is a unique one. Some of them did other things like determining a perpendicular vector that is perpendicular to AB and perpendicular to the normal. So that was pretty smart. I thought that was maybe the smartest way to go about it. And then you could find the, what do you call it? You could find the, what's it called? The size of that normal vector, and then you just did 1 over square root of that to get the 1 over that to get it as a unit vector of 1. So yeah, you would do AB times 1, 3, 2, and then I think the length of that was like 30 square root of 35 or something. So you just square root of that 1 divided by square root of 35, and then that would get you a value or a length of exactly 1 meter. So yeah, but this was the final solution. There was like 3 solutions to this, and I'm surprised I didn't even use any of them. I came up with my own one. So yeah, pretty cool that I found another solution. So that makes the total solutions to this question 4. There's probably way more than that. But yeah, the perpendicular to AB and perpendicular to normal was probably the one I was probably the closest to actually getting, and the one that I understood the best. The other ones were like making lines and stuff. I don't know. I just had a quick skim through it because I was marking fast, but yeah. Cool, 91.7%. So we're gonna do 2023 now. Let's go.